The change of y over change of x. But y's can be written as this. And take it from there. M is the slope. I'm going to send it to y'all. I went through and looked online for the most comprehensive ones. I'll send you the algebra ones, the trig ones, and the calculus one stuff. Yes, I'll send you everything I can. So who's going to sit up here and I'm going to figure out where everybody else is hiding. We're working on that first test, that the calculus one review test. So everybody's working together. Okay. So remember, don't just work out those stuff. You have to explain to your colleagues what you're doing, because they have to understand when everything's done.
I mean, essentially, I'm just plugging everything into this formula here.
So you're plugging in 4 and 7.
Exactly, yeah.
Yeah, 4 is the x1, 7 is the x2.
And I'm just plugging it into its corresponding area.
Yeah, that's, I need you, whoever's right there, and take turns, just one person. No calculator.
No calculator.
Calculator for this.
No. Okay.
I don't want decimals, I want fractions.
Okay.
Okay. Everybody in the viewing audience, if you don't understand what he's doing, it's your job to ask.
That's from the beginning again.
So from here. So basically what I'm doing is this is our f of x, and these are our x1 and our x2. I'm plugging in the x1 or the x, sorry, I'm plugging in the x2 into our, like, I'm combining the f of x and the x2 and the x1 and like plugging x into,
Calculus one.
I don't know how to, sorry, like I'm plugging in the x2 into the f of x where x is, if that makes sense.
Really?
So you're plugging 7.
I'm plugging 7 into where x is for our f of x sub 2. And then when it comes to f of x sub 1, I'm plugging in 4 for our f of x. It's,
You understand so far? You understand what you said?
I understand plugging in, but it's just confusing looking at the numbers.
You know, sure.
I'm not the best at explaining, so it's
No, and that's it. By explaining, you're strengthening your knowledge. Okay. These are our interval. That's our interval. That's x1, that's x2. So our formula for this first part, x2 is this. We plug it into here. So it's 3/7 minus 2. That's this number. Minus with x1. Minus x1. So it's 3/4 minus 2. All of that over x2 minus x1. And he just worked that out.
Okay. Okay.
Okay, and now this is the part we get tripped up on. This is the hard part we'll have with the hate fractions. And by law, you cannot have better handwriting than me. Yours is beautiful.
Do I?
Oh God, compared to mine?
Yours? I mean, yours is nice.
You didn't get to that. What's the rule for fractions? When you're subtracting fractions, what's the rule? You have to have a common denominator. And that's what he did there. That's what he did there. This one, 2 times that makes it 10 on the bottom. This one, 5 to here and here. Because now the bottom is 10. By the top. But now this is a complex fraction, a compound fraction. You have a fraction over a fraction. This is 3/1 on the bottom. So we take the top fraction, leave it alone, and then multiply by the flip of the bottom. Yeah, so on the denominator it's 3/1. Put 3/1.
Oh, yeah.
Yeah, so leave the top fraction alone, so it's negative 9/10. Times the flip of the denominator fraction. Cancel what you can. Yeah. Unfortunately,
It didn't record.
it did well. It recorded, but it's always going to be here. It's recording this page. Because what I have to do is I have to come over here and switch between channels to record those.
If you just screen, so
I'm live streaming this, so it's videotaping as we're talking.
whenever you put share, if you put screen, doesn't that doesn't record the screen now?
It only records which one I have highlighted. We'll see.
But you see that first one, it says screen,
Now, if I go to the screen, if I go to this, it's still taping the
no,
paper.
so you see right there where you're at, that first one, it says screen on the bottom,
This one?
yeah, you see right there's the screen.
Yeah.
So whenever you do that, it should just record whatever screen you go to.
Really?
It should, that's how it is.
See then, if I go to here, is it showing me that? You are absolutely correct. You just saved me 1,000,000 hours of popping around back and forth. Thank you. Okay, that's the first question. Who's moving to the next? Did you pick the answer?
Mine's right.
It's a test. It won't tell you anything until you've done it. Okay, who's going to do the next one? Isn't it the same question?
It's the same here.
You should do the work. Even if you can't log on to it.
I fix it.
Do I need to do it in a different paper or
No,
just in the bottom?
okay, on the very bottom, where's, I think the mouse is there. Yeah. What we should do is just pop between this and this, or just hit that one twice. It'll take us back and forth.
Mhm.
So there's that question. You have it written down?
Yeah, write it down.
Here, what we're doing is we're working as a group. Because not everybody finished this. I want you, because in order to do calculus 2, you have to understand calculus 1. And that's what we're trying to do here with this review, to see, to get the basic concept down, and then we can move on as a group.
What means slope?
M is slope, little m, capital M means midpoint.
Yeah.
Okay, look on the screen because that's what they can see.
Yeah.
So whatever's up, always when you just click on the white box on the bottom, and it's going to switch between the question and our writing screen. I was getting worried earlier. I thought class started at 9:30, nobody's showing up. I said, where are they? And I was told it's up at 10.
So now we can substitute the values after we make the equation.
Go where it says content. Yeah, I'm down in that dark. Go to my lab. No, you just have that right there in front of you.
This one.
Yeah. And then the top one says my lab, all assignments. It's the very top one. Hmm?
If calculus.
That's what I'm doing right now. But everybody should be doing this at their desk also, because you have to tell them whether it's right or wrong. Remember, whatever he puts up there, that's gonna be part of your grade. You know, everybody shares in the first grade.
Can you look at the paper so we can see?
Oh.
Yeah, I want to take the screen so you can see what we're seeing.
So all I need to do is sum it up. Yeah. I think this is the answer I got. It's 194 minus 194.
That's, I mean, everybody else should have done the same thing. You see, that's the right answer.
So all I did was get the equation of slope first, which is delta y upon delta x. Then similarly, difference delta y means difference between y, so it's like x2 minus x1. Same for the x2 minus x1. And all we did is substitute the value xt from here to here, and 1 from here to here in the main equation. So and that's all how we did it. But I think the answer should be -3 or something like that.
No.
-34. Yeah. I don't know. I messed it up in calculation or something. Mhm.
I think negative three and one way to,
So you're talking about this line, right?
yeah, so that first.
Okay.
Well,
Let me see. Shit, it was supposed to be positive, right? So this negative goes multiply this, so it becomes +3, positive 75.
well, I don't know if there should be. I'm talking about the.
Yeah.
In the beginning of the negative three x. Where?
Right here.
Yeah, so in front of that three.
Mhm.
Why is there?
That's the original question. Look at line number 2. See number 2? Under his finger on top left. The original question is -3x squared minus x.
It's already negative in the equation, so.
Oh, yeah.
But I got something out of it. Actually, I made an error right here. It was supposed to be addition. So now we can do it again. So it's
And that's the reason we're using my computer, because when y'all log on, it'll just generate different numbers. Same process, but different numbers. So that's why we're gonna use one computer for the grade for the whole class. First, if you logged off and logged back on with that same question, you'll have different numbers.
Oh, okay, so I shouldn't even pay attention to this.
Then, yeah, it won't stay the same. I mean, if everybody got the same question, they all may have different numbers.
Okay.
Is it fine now? Where?
-108 -6
And this one?
No. Put it at the end.
To at the end?
Like right, yeah.
So it's supposed to be positive.
It should come out to -34.
Okay. So right here, -108 -6 should come out to -34 right here.
Yeah.
Okay. That's it, right? Yeah. So we got our answer. So everybody got it, right?
Everybody answered yes. You understood it? Yeah. Who else is going up there? I think somebody who has a hard time with it should go up there. But that's the best way to learn it. Jump in the pool and start swimming. I tell you what, whoever goes up there picks the next person to go up there.
I think I like that idea.
That way I only have to upset one person. So just pick somebody.
Does he pick somebody right now?
Yeah.
You want me to do it?
No, here we go. You can't repeat until everybody else is done.
So you can go ahead and raise your hand.
That's not a picking, that's asking.
So it's just that don't know what to do. Maybe are you going to do it?
Well, you can't say no, everybody has to go. I mean, you can't get, if you get stuck, we're here, you guys are here to help them.
Yes.
So it's, everybody has to go there eventually, so it's not gonna be any different.
You can walk through. But if someone gets that going, like, maybe we can all work together, but we just need someone on the test. Yes. Thank you.
It's, if you have a hard time, that's who should be up there. You should, that's the way you're gonna learn the stuff. Because when you're sitting back here, they're doing everything real quick. You're just tagging along, listening, and then trying to regurgitate what they're saying. I feel that. I mean, it's no reason to be embarrassed. Not about, actually, and this is algebra, actually. It's even worse. It's even harder. So no, do not be afraid whatsoever. It's everybody here's, everybody's a friend of everybody else, so.
Okay.
Yeah. Semua tidak kasi kaya isma sa equation computer next one no oh yeah this one yeah, this one here plan igagawa and start ko on I said sorry
Look for a slope. Slope, rate of change, average rate of change, all those mean the same thing.
Yeah.
What is 5 cubed? It's 125, not 75.
Oh, sorry.
5 times 5 is 25. 25 times 5 is 125.
But you don't want to. Oh, that's.
So everybody got the answer, or like is something wrong? Oh, yeah.
Question. Is -1.5 a point or an interval?
Oh,
Me, like on the.
A point is a location, a dot on the curve. The last two questions we had, it gave us an interval of points, x1, x2.
Hmm.
And you're solving it the same way we did the other two. Of this one?
Yeah.
But scroll down, let me see the question, what's asking. Find the slope of the curve of the given point P on the equation of the tangent line at P. Yeah, so the point they're giving us point P. That's not x1, x2, that's xy, that's point P. And they're giving us that curve.
Put wire there, and then wire next under the line.
just the X1 and Y1.
Yeah, it's treating it the way we did last time. And we can't do that. We have to think of something new here.
Oh,
What did you say?
I said, this is the formula for how they do it.
This is exactly, that's the formula for average rate of change. We don't need that.
That's orange.
Good, and that's called the difference quotient. And we have to look for here now, since we're looking for a slope of a point on a curve, we have to find the limit, or we can use the first derivative.
yeah.
Right, we can use the derivative. Because remember, what is the first derivative find?
Minus 3x
No,
squared.
but what does it find? When we find y prime, what does that represent?
That's the slope of the.
That's the slope of the curve at that any given point.
Mhm.
So all that stuff you did in there,
And
it looked
now you
nice,
have-
but It wasn't right.
I'll do it again.
Did you know from the beginning?
Well, yeah, I mean, yeah, I love what you did, dude. Beautiful, logical steps, but you didn't answer the question.
Oh, yeah. So I will do it again.
Now use that as a point,
Okay.
and we have to find the slope of the tangent line. And remember, the slope of the tangent line, how do we find that? Well, we find the slope and plug in those points and see what we get. If you were looking at doing it, the difference quotient. The difference quotient is how we first started in calculus one, how to get to the derivative. Once we find the derivative, then it's a shortcut. Yeah, we can skip all that, and then we have to do the limit stuff either. So let's just jump and do the limit. This is bring back some memories from when you calculus one. Yeah, calculus one. Calculus one finds the rate of change, the slope. It also finds the area under a curve.
Yeah, I try to watch YouTube videos like a week before class started. Not really.
No, and that, again, that's why I have no problem starting off the first week or two this way.
Yeah, that's what I was thinking. I know there was the formula that we just put everything in. And I used to have a sheet with everything.
If you have, yeah, but that's not, I will send you all the trig functions, the identities, the trig functions, the calculus one notes, and so. Okay, now -3. What does that represent?
Oh, that's represent the slope of the given curve.
That's the slope of the curve, isn't it?
Yeah.
At that point.
Yeah.
We want the slope of the tangent line.
And we have to find, I think, the equation of tangent line and the slope of given point in P. Slope of curve, like find the slope of curve at the given point P and the equation of tangent line.
Okay. I was mixed up, yes.
Okay.
So you found the slope, now you can find the tangent.
Yeah.
The same way you did earlier.
Yeah, I did the same idea.
Does everybody remember how to do the derivative using the power rule? A whole bunch of rules, but the rule we use here. On the power rule. If y equals x to the power n. It's an exponent. The first derivative. Bring the power n. And so
I have.
that's a derivative. So in our case, we have, and there's also no limit constant. Yeah, so the derivative, why is that? Derivative of a constant. is- There's no rate of change, it's a straight line. Yeah, if y equals 3. The derivative of that, the slope of that is 0. Because if you think about, what does the graph y equal 3 look like? the slope of that line.
That's just.
The horizontal line. Constant is a horizontal. And so in ours here. We have two separate equations. The derivative. The derivative of 4 is. Minus the derivative of x to the third. The first derivative is negative. Oh, we can.
Like you come.
Yeah, the second derivative. Like if we're using now. I need everyone coefficient. Bring the 2 down and multiply it, so it's -6 minus 1 x. And the third derivative. That's a 1 up there. Move it down to -6. 1 minus 1 is 0. X to the 0 is 1, which is let them up. But the third derivative is that. The fourth derivative is like a constant. Yeah, you can keep on going second. But yeah, I also give you some the formulas and rules for all the other ones, the power rule, the chain rule, the quotient rule. But as we go on, that's just the power rule. That's the first one we learned.
So everybody get this? Is there any confusion?
Everybody agree with that?
What is it for the?
The formula
For the tangent one?
or the formula?
Well, that's what you're-
This is the
That's the original line, right? Everybody agree with that? Plug it in there. So on the very bottom bar, see it, the white box on the right, pick that one. Now, let's see, does it satisfy any of those? Right, is this your room?
You said it 11.
Minus. Oh. Well, it was, 25 live, so it's empty all week.
That's a glitch because we've been here
Have
from
you-
first day.
Okay, yes, so, all right, then we'll go ahead and pack up.
I apologize.
Oh, no, I apologize, it's 25 live, so it's empty, so it was a nice cool. All right, let's go down. Let's go back to the other room then.
okay.
I'll leave that locked on there.
But we have plans on Tuesdays and Thursdays from 11 to 1:30. So if you have another day,
Well, no, my other one works perfect. It's just that this one was. We have a room that's not really conducive to anything.
well,
Yes.
this one was really hot for a while. And then I figured out that it would take about 15 minutes for it to cool.
And when the computer works, remember, she couldn't just now logged on to. Brightspace, we'll just find it later on today.
Yeah, that has been a challenge for me for just all the technology that I've been trying to use. Because I think that Blackboard.
Yeah.
I'm familiar with Brightspace, but I think that's some students that they try to use Blackboard.
And you can't do that. But you go in the same way you do get to the Blackboard.
Yeah, but you can't. So that.
Again, I am so sorry. When I looked at it, because the room we have is 196, and it doesn't have the screen is on the floor. The tables are set up in a U shape. But they have, because they have computers on them. And that doesn't do us any good. Yeah, I cannot.
Okay.
Now that I know.
I saw you here at 10:30.
Yeah, they gave me this for my 8 o'clock class. Well, maybe I have it, if nobody heard of it, I have it. Well,
All right, yes, yes.
okay.
I know I did that last week.
It looked,
Nothing like.
Yeah, of course. Wow, all 6 of y'all can sit here. Perfect. If everybody else shows up, we're stuck. Yeah, I thought it was too good to last. We had a beautiful room, air conditioning, everything. Yes. Y'all have a class at 9:30? Does anybody have a class at 9:30? You have a class at 9:30? Today. But I'm saying, instead of starting at 10, we could scoot up to 9:30 and be out by 11 when they start their class. Would that work? I never thought about that. Oh my God, this whole room's falling apart. Okay, and did we enter that as an answer? Okay, so here we have another question. This is question 4. So what's the rule about this one? What exactly is a limit? Is what? Well, it is a number, but what does a number represent? Yes. Let's say we had a curve. So let's say we had a point right here. So the closer we get, closer and closer we get to this point here, we get to a limit point. These get closer and closer and closer. These are our epsilons. These are our deltas. So as delta gets closer to 0, in other words, as this distance between our point C and our delta, as these walls get smaller and smaller and smaller and smaller and smaller, these walls start approaching our limit value. So as delta goes to 0, epsilon goes to 0, and then we eventually get to a point, which means what happens means is our points in our graph get closer and closer and closer to our real value. It gets closer, 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 closer. So how do we find the limit? What's our first line of defense? Plug in the limit value. If it works, it works. If it doesn't, then we do something else. Is there an x in there anywhere? So the limit of a constant is what? The constant. Because this function is a horizontal line. No matter what point I pick, it's always going to get closer, closer, closer to, I mean, this is always going to be at radical 10. Same thing here. No. Right here. If there's no x, it's a constant function, so it's just that's the answer. Because it's a horizontal line. Remember, we're looking for the y value. Because, like you said here, the limit is the y value that you're approaching. These are the inputs. You're eventually getting close to a value c. That's your x value. As x approaches some value c, our function approaches some value L, or limit value. And that's what it's all about. But there are a whole bunch of different rules about that, as there are with derivatives. So this one says the limit as x approaches -8 of our function 12x plus 1. I am so glad you told me about that. The screen button. That's the same because I used to always go and switch everything. And it's whatever's on your screen makes sense. I always thought that that's the screen when you logged on. So, again, what's the first line of defense and limits? Plug it in. So we get 12 times -8 plus 1. Positive times negative is negative. So 96, -96 plus 1 is -95. And that's your limit. Makes sense? So again, whenever you have limit functions, just always first step is plug it in there. If it works, it works. If you have fractions and you get 0/0, what can you do? Well, for example, if I had the limit as x approaches 3, right? Because if you plug it in there, you get 0/0. There are two things we can do. One, we can try to factor. The top part is the difference of two. And we can cancel those. So our real function is that. When we plug in our value as x approaches 3, we get 3 plus 3, we get 6. Or you can take the derivative of top and bottom. It's L'Hopital's rule. There are a whole bunch of, again, you had 16 weeks of rules that we have to try to catch up with. So that one we said was -95. There you go. Who's going to take over my job? I mean, we're unless you know this stuff 100%, I don't want you guys on your cell phones. I mean, don't text or anything because we have a lot of stuff to cover and I don't want to waste your time to waste. I don't want you to waste my time. It is awful.
Is it blurry?
Now I can see it.
Okay. So just plug in the negative
All
2.
this person just plug it in there, your limit value, and see what you get.
So if that's already a negative, does it become a positive or?
Ooh. There's a difference there because it's negative x squared. So wherever you input that -2, put it inside parentheses. So everybody see x. Open parentheses, yeah, -2. Yeah, and you really don't need, when you plug it in there, you don't need the outside parentheses. But that's okay. So now, order of operations, what do you do first?
This one?
Exponents. So -2 squared is what?
-4?
-2 times -2 is
4.
positive. So it becomes a -4. The negatives out front. Positive 5 times -2. So positive times negative is a,
Negative.
it's gonna be a minus sign. 5 times 2. -4 minus 10,
-14.
-14. They both negative, so it's -14. -14 minus 8. They're both negative, the answer should be negative.
Mm,
What's 14 plus 8?
12, 20, 22.
Yeah, so the answer is, we can't see. No,
No,
or we're not finished yet.
I need a calculator.
You don't need that.
Okay, hold on.
They're
14.
both negative, so the answer is the answer gonna be positive or negative?
Negative. It's negative, right?
It'll be negative. And since they're both negative, add the two numbers. 14 plus 8 is,
22.
were you gonna write 22 earlier?
Yeah.
Okay, I'm sorry, I spoke too soon. Yeah, that's your answer. So put that in. No, for the box. Yeah, press that button. It's easier for us to switch. Try another one,
I can.
or do you wanna pick somebody? I know, you look at the faces, you're gonna upset somebody.
Everybody's like, okay. I'll pick somebody. I don't want to do this anymore. You can go.
Fractions.
I don't know. I prefer even do math.
We'll get you there.
I use Excel.
Okay.
I use Excel at work. So.
I usually said it is, yeah.
I know, it's like, yeah. So it's stuff, whatever.
It's the white button.
Is that which
To the left,
button?
to the left. No, other left,
This one?
yeah, yeah.
Didn't even see the question.
Did you write the question down?
Mm.
No, do the white button, yeah.
No, I want to see
Do
the.
that.
Okay.
Constant number where you get zero.
You can get a fraction, you can get a integer, you can get anything. But if there are certain rules, you can't get zeros on the bottom. You get zero on the bottom, it's undefined, it's showing something else. You get 0/0, that means something can be simplified. So you have to put the algebra part and simplify it. Yeah, there are a whole bunch of different rules or procedures you can go about this.
Let me just back.
That's if you get a number over zero.
So you said.
Well, first you would try algebraic and see what happens. Like right now, see, it's gonna be 0/0. So 0 divided by 64 is 0.
It's a zero. Then it's a zero.
And so you have 0/0, so something else can happen. No, you're not done yet.
I'm not done.
Undefined, it's not 0. You cannot divide by 0. Because you have two fractions here. You have the fraction on top, which is 0 divided by 64. Divided by 0 on the bottom. You have to treat both of those separately. No, it's 0/0 now, because 0/64 is 0. And then that's over 0, so we have 0/0. So that means something can be simplified here.
Something can simplify.
You can do something to make it so it's not gonna, it'll give you an answer. So you have to do algebra now. So on the original equation, work that one out. Combine everything, simplify it.
Okay.
Is X. Divided by 8x. Now times, take the reciprocal of the bottom. You can't see your screen. Okay, yeah. So can anything cancel?
Yeah, we can cancel X minus by.
Can cancel. Oh no.
So the put parentheses around the 8 minus x. Just the top part, parentheses, not absolute values. Okay, not the entire equation, just the numerator.
No, just
The
anymore.
top number.
Okay.
No, just the top, no,
Just this one.
just those, yeah. And the x minus 8, put that in parentheses. Right. So now, the reason you do that is because you have to separate those. If you don't, then what you'll have on the bottom is 8x squared minus 8. And we can't do that. So can anything cancel? Yes, the two parentheses can cancel. How are they the same? And now on the top left, what can you factor out?
I can remove
A negative one.
Negative one.
Yes.
Can I cancel?
Where did the negative one come from?
In the top left-hand corner, you have the in parentheses, -8 plus X. We factor out -1. When we factor out the -1, then it looks like the bottom right hand
Oh, it's the negative one.
times X minus 8. Because now the two corners cancel, so we have -1 over 8X.
No.
Okay, you can combine -1 times 1. What is -1 times 1?
It's just negative one.
Perfect. Excellent. So this only works if you have 0 over 0 in the first one. When you first put in the limit, if it gets 0 over 0, then we can do something like this. Any questions?
So it's 0 over 0 minus 0.
Right, now because if only one top and bottom are 0, if the top is 0 and the bottom is not, then the answer is 0. If the bottom is 0 and the top is not, then it's undefined. But if 0 over 0, that means both the top and bottom, something cancels out, we can simplify it. Okay, who'd pick? Let's start over again.
The second one.
Oh, you haven't been up yet, have you? You stuck out. You got so lucky. You tried to say quiet and lay low. Sneaky. Put that way, and we'll enter that answer on the. So we'll answer that one as. Another way, for your homework assignment, you don't have to go to this page here, you just hit the slash on the bottom next to the space bar. There's a slash that'll make a division for you. Look, you go. Right, this is down for us, and that's good. Let's do it. So is this bringing back some memories? Is it taking off some cobwebs? It's like riding a bike. If you don't do it for a while, you forget. You have to leave it on.
It doesn't matter what negative is when we put in here.
Wish I had calculator right here.
Okay, the 3 to the 4th is like 3 squared and 3 squared. What is 3 squared?
9,
9 times 9?
81.
It's 81 minus 81. Three times 3 is 9. 9 times 3.
Big.
Then
27.
a good rule of thumb is just in case you have to say yes, then you're usually gonna get 0 over 0. So it's 0 over 0, so what do we do? Now comes the algebra part. There's no always like calculus fast. Calculus is only the first step of each problem, and then the rest is algebra. Because everything that you do here now is algebra. So you have to factor top and the bottom.
I can think it's a little bit.
Let me do it for you. This one? Because this one is, the top is the same as the difference of two squares. And the bottom is the difference of two cubes. Remember those formulas? Yes, but yeah, it's, let me do this one, because it's, again, these are the formulas I have to give you on those sheets. Okay, here. The difference of two squares is a plus b, a minus b. The difference of two cubes is just whatever's here minus the exponents. Now the remainder of them are here. If that's a minus, this one has to be a plus. So far, so good? So now, how does this relate to this? Well, u to the fourth is u squared squared, and 81 is 9 squared. So this is A, and this is B. U cubed 27 is the same thing as 3 times 3 times 3. So that is A, and that is B. So we have u squared minus 9, u squared plus 9. That's what that one says. U minus 3, u squared plus a times b, 3u plus b squared, which is 9. But we haven't gotten too far, have we? All we did was factor them out. Can we factor anything else out? Which one? Yeah. We could, this one here. It goes there, so it's u squared minus 9 is the same thing as u squared minus 3 squared, which is u plus 3, u minus 3. Very good. U plus 3, u minus 3, u squared plus 9, u minus 3, u squared, 3u plus 9. What cancels? And now notice that all of them are plus. So nothing's going to go to 0. So as our limit, as u approaches the positive 3, plug and play. Nothing's going to go to 0. So 3 plus 3
3 squared plus 9. 3 squared, 3 times 3 plus 9. Three plus 3 is 6. 3 squared is 9. 9 plus 9 is 18. 3 squared is 9 plus 9 plus 9. So far, so good. What do they both have in common? Before we don't have to multiply anymore, we now start simplifying. If you think about it, 6 is made up of 2 times 3. 18 is 9 times 2, right? So it's 3 times 3 times 2. 27 is 3 times 3 times 3. I made it look easy. Put that cell phone away. You don't need it out. Do you have a cell phone out? Is your cell phone? Again, it was all algebra. There's nothing. Calculus was just here. Once you do that, it's all algebra. Right. And that's the hardest part. Really, the hardest part is trying to remember all the rules. What's that? I don't hear. Nope. Everything you do in calculus 1, 2, and 3 will always break down to the algebra parts, which is why algebra is needed as a basis for all levels of math. Oh, this is pretty easy. I can do this one. I'm gonna do the easy ones. You wanted to do this, didn't you? Let me write this one down. This is number 9. So suppose the limit of f of x as x approaches b is 4, and the limit of g of x as x approaches b is -3. Find the following. Limit of f of x plus g of x as x approaches b. The limit of 9 times g of x as x approaches b. C, the limit of f of x times g of x as x approaches b. And D, the limit of f of x divided by g of x as x approaches b. What this one's really telling us or asking us is, do we remember the rules of limits, of expanding or combining limits? Basically, what is this one telling us? What it's telling us is this. If I had limit of A plus B, that's the same thing as limit of A plus the limit of B. Limit of A times B is the limit of A times the limit of B. Basically, that's just saying is how we distribute and work it out. So we really don't have to do much. F of x plus g of x is what? 4 plus -3. 1. 9 times g of x. So 9 times -3 is, it's going to be negative. 9 times 3 is 27. F times g. 4 times -3. -12. F over g. 4 over -3 or -4 over 3. It's not common convention to have a negative on the bottom, so we move it to the top. And that's all there is to that one. Yeah, I did it. Any questions about these? So this one's going to be 1. -27. -12. -4 over 3. Ooh, what does this one tell us? Or asking us to do? Remember what the name of this was? Right down here real quick. Remember what this formula was? Another name for it? Very good. This is the difference quotient. The difference quotient you actually learned in algebra, and it showed us that the difference between two separate points on a curve, and you can find the slope between the two different points on a curve by those points. Then we learned in calculus that if we take that and find the limit to it, then those 2 points get closer together and we find the slope of a curve at that given point. So that's what this is looking for. Basically, here's our curve. X squared is a parabola. It wants to know what is the slope when x is -5. What is the slope of that tangent line? Using the difference quotient. It's easy, but who wants to do it? Who wants to do it? What this question is asking you to do is, we have a difference quotient. That just, the difference quotient finds the slope between 2 points on a line. It finds the secant slope, the slope of the secant line. It crosses a curve. Now, once we put it in the limit function, that means that the distance between those 2 points becomes closer, closer. Eventually, they become the same point. Therefore, this actually defines the slope of the curve at that given point, of the slope of the tangent line at that given point. So, no. We're looking, the function is x squared, but we want to know what is the slope of the tangent line when x equals -5.
So it's gonna be at negative 525, it'll be at that point. What's the slope of the curve at that point? So how do you figure it out?
Use the different equation for that.
Yeah, we use that formula given, it gave us the difference quotient. The f of x plus h minus f of x over h. Who wants to volunteer?
That is right.
Yeah, of course. Of course. That's the best way to learn. Pilot will never become a pilot unless he gets behind the controls.
I'm sorry, I don't know a thing, but I still want to try it.
Okay. So the first thing you have to find is what is the f of x plus h?
Yeah.
What's that gonna look like?
So that will look like x squared plus 0 and
No, it will be x plus. Because inside the parentheses, it's f of x plus h. So inside the parentheses,
Mhm.
anywhere I see an x, you put an x plus h
anywhere I see x
in the function, in the given function.
in the given function. So this x becomes x plus h.
Where's your function?
Oh,
Right there, yeah.
okay, my bad. So it's x plus h whole square.
Right. That's the first part.
So this one is for f of x.
No, that's the f of x plus h.
Okay, it's x plus h with it.
So now, yeah, so the first thing you have to do is define what is the f of x plus h.
It's
You have
x.
the function, so yes, you have it there. Now start plugging everything into the equation of the limit.
Mhm. So it's x plus h whole square minus x square upon h.
Good.
Do I have to write s tends to 0 all the way to the bottom?
With the limit.
Okay.
Yeah, because it's the limit as h goes to 0 of that equation.
So it's 2 into x, 2x, and 2 in minus 5. So it's 10.
No, it's not 2x minus 5.
Oh, it's multiply.
Because we have to first take the limit. When h goes to 0,
Yeah, it goes to 0. I already
so
did.
h disappears, h goes to 0, disappears.
So this goes out.
No, the h disappears. The h, anywhere you see an h in your equation, it now becomes 0.
Nice. Anywhere I see h, it becomes 0.
Okay, erase the, so scratch out the bottom line you have there.
This one?
Yeah, the whole bottom line.
Okay.
Okay, now, from that, now that one is, what do you have left?
I do have 2x plus h.
Write it down, put it down on the page.
Okay.
Or, yeah, limit h goes to 0 of,
Right?
well, it's not equals, it's the limit of that as h goes to 0.
Okay.
So now, anywhere you see an h,
Mhm.
what does it mean? What do you do?
I'm going to plug in 0 on it.
Put 0 in place of h, right?
So it's 2 into x plus 0. That will be 2x, right?
Yeah, there's 2x,
And I plug in the value of 5, x.
right?
So it's minus 10.
That's your answer. That's the slope of the curve of the tangent line, the slope of the tangent line of the curve at that point.
Slope of curve at tangent line.
That's the slope of the line tangent to the curve. The slope of the line tangent to the curve. At x equals -5. Yep. Now, is there a shorter way to do that?
Sort of way. Maybe we can use delta. No.
Nope. That's the longest way.
Take
Take the derivative, because the limit of the difference quotient is the derivative.
Yeah, it's easy, right?
So the derivative of x squared is what?
2x.
Correct.
Right there.
So
And
the derivative of x squared is 2x. Plug in -5, you get -10.
yeah.
We can't see what you're writing.
Oh, sorry. I'm just. It's on the top.
Yeah, it's a power rule. It becomes 2x. So that's the slope. The first derivative is a slope. So we put in -5 and we get our slope for the curve, which is the limit of the difference quotient. Because the derivative by definition is that equation. The limit as h goes to 0. That's good. That's a good question. That's a good question. Let me show you all this stuff.
Because in algebra, finding the slope of a line is pretty easy. We can find 2 points and do the slope equation. But once we have a curve, and if we pick 2 points on that curve, if we draw a line between there, did we find the slope of the curve? No, we found the slope of the secant to the curve. We don't know anything about the curve yet. So what we're doing here is the first derivative is the slope. This is what we're getting to. So this is x1. This is x2. This corresponds to f of x1, and this is f of x2, right? That's if you know both points. If we only knew this one, if we only knew x1, f of x1, if we only knew that, how do we go from here to this point to this point? How do we go from here? How far is this right here? That's h. That distance is h. So horizontally, we have x1 plus h equals x2. So if I go from x1 and I add h, I get x2, right? So that means h is x2 minus x1. Same thing here. So now anywhere I see an x2, I put an x1 plus h. Got one there. F of x2 equals f of x1 plus h. Follow me so far? Because all I did was define I redefined x2 in reference to x1. So let's find the slope. We have y2 minus y1, x2 minus x1. Well, this is f of x2 minus f of x1. F of x2 is this, f of x plus h minus f of x. x2 minus x1 is h. That's the difference quotient. So that tells us the slope between the 2 points. Now, When we take the limit of it as h goes to 0, what's happening in this picture? Remember, the distance between x1 and x2 is h. That's what h is. As h goes to 0, that means this point gets closer and closer and closer to this point. And eventually, the slope that we're finding becomes a slope of this point, and it's a tangent line. That's what that tells us. So this tells us the slope formula, and this says because the distance of the 2 points are 0, it's the slope of a single point on a curve. And that slope, it has to be a tangent line. Did I confuse you even more, or did I answer your question? Well, again, it's all algebra. Everything, calculus is nothing more than turbo algebra. It just does algebra stuff much faster. Well, yeah, what we're looking for is this. If I have a curve, I don't care what the curve looks like. It could be a cubic function. And I said at x equals, let's say 1. What is the slope of the curve at that point? And since it's the point on a curve, it has to be the tangent to it. So that's what we have to use. Since it's that, the slope is the limit as h goes to 0. Which is also our first derivative. Because this defines our first derivative. Well, yeah, again, we're trying to cram 16 weeks worth of stuff, or 2 or 3 weeks in the first part of Calculus 1 into 5 minutes worth of lecture. But that's pretty much all it means. That's what the difference question is all about. Is finding 2 points on a curve. The slope of those 2 points. So what was our answer here? -10. Ooh, this is an epsilon delta proof. We'll pick up from here next time then. Because now comes the long, hard, drawn out ones. Because with these, we have to set up the equation. This is XC, this is FL. This is the epsilon delta proof of a limit. This one, what this one's saying is, as X and C get close together to each other, first off, what is X? We had a curve. The C is the value we want to get to. X's are this is the axis. This C, once we put the function at C, we get the limit. So this corresponds to the limit. So as our X's get closer and closer and closer to C, as these get closer to 0, this becomes infinitely small. So as delta gets infinitely close, as the X gets close to the C, what happens? The Y values get closer to L. That's what this one says. Because as epsilon gets mighty small also, infinitely small. This difference, if it's less than this, it has to get closer to zero faster. That's what we have to do, because we here, first off, we have to find these values. And then we do it algebraically. And that's what we're gonna do next time. Yeah, this is the part I apologize to my calculus 1 class because these take a long time. And then once we got out of this one and into the derivatives, life was easy. So we'll call it time of death 12 o'clock.